Hi guys, today I want to talk about the fundamental shift that has reshaped how we build applications, moving the centre of gravity from the server to the client. For decades, the dominant model involved server-side rendered frameworks. Think Ruby on Rails, Ash.NET MVC, or classic PHP. They delivered fully formed HTML with JavaScript, primarily for progressive enhancements. Then came the rise of the powerful client-side frameworks, and with them, a revolution in application architecture. Today we're dissecting the two pivotal forces in this transformation. We've got React.js and React Native, and critically, the role of Angular and TypeScript in paving the way for this client-centric era. We'll explore how this shift allowed technologies like React to ascend to their current dominance and the architectural implications for modern distributed systems. Okay, so the rise of client-side rendering in Google's role. To truly understand the modern front-end landscape, we need to acknowledge the groundwork laid for client-side rendering. While Ajax had been around, it was the emergence of comprehensive JavaScript frameworks that enabled the truly rich single-page applications. Google played a monumental role here with AngularJS, and then the complete rewrite into Angular 2+, which famously adopted TypeScript as its primary language. This was a strategic move. Traditional server-side frameworks like Ruby on Rails with its active record and Ash.NET MVC with its Rails reviews were powerful, but they tied the UI closely to the server-side logic and database models. Scalability often meant scaling monolithic servers. Angular paired with TypeScript offered a compelling alternative. It pushed the entire rendering responsibility, complex UI logic, and client-side routing into the browser. This decoupled the front end from the back end, allowing teams to develop independent APIs, for example, REST API or GraphQL, and have dedicated front-end teams. The type safety and robust tooling provided by TypeScript, especially for larger, for example, Google scale projects, gave developers confidence in building complex client-side applications that were maintainable and scalable. This shift wasn't just about rendering, it was about transforming server-side application development to a pure API provision role, enabling microservice architectures and distributed systems where the front end consumes services from a disparate back end. Okay, so let's look at React.js, the web's the current dominator of the web and its ascent. Against this backdrop, React emerged with a different philosophy, a highly flexible, performant library focused purely on the UI layer. While Angular offered an opinionated, batteries-included framework, React provided a view layer that could be composed with other libraries for routing, state management, and so on. This flexibility resonated strongly with a lot of developers. React's core innovations like the virtual DOM and the declarative component model we discussed led to unparalleled performance and a highly intuitive developer experience. It became the preferred choice for startups and nimble teams who valued rapid iteration and a less prescriptive approach. But how did React manage to eclipse Angular as the most commonly used web application framework? While React's technical merits on the web were undeniable, the significant accelerant to its broader ecosystem adoption was the sheer gravity created by React Native. So what's React Native? Let's look at React Native. This is the crucial pivot point. When Facebook released React Native in 2015, it wasn't just another mobile framework, it was a game changer that leveraged the same declarative component model and much of the same knowledge base from React.js, but targeted native iOS and Android components. Now it's important to see the difference between a native app and a web-based app. I think the key thing that I always explain to people is when you look at Spotify and when Google Music come along, Google Music failed because if you use Spotify against Google Music was sluggish and difficult to use in comparison. That was because Google just wrapped up web page whereas Spotify used native. That's a good example of where native apps always perform a lot better than basically wrapped up HTML apps. Think about the applications for talent acquisition and development investments as well. As a software engineer proficient in React for web development, you could now, with a relatively low learning curve, transition into building truly performant, truly native mobile applications. So you could use the same tech for both. This meant you expanded the talent pool. Companies could hire React developers who could work on both a web and a mobile project. Skills transferability. Developers didn't have to learn an entirely new paradigm like Swift or Kotlin or even other cross-platform solutions to enter mobile development. This lowered the barrier to entry for mobile app creation, and a unified tooling and ecosystem, libraries, development patterns, and even a significant portion of the Mac ecosystem like Redux became applicable across both web and native platforms. This shared knowledge accelerated development across the board. And basically mono repo synergy, which is quite common with a lot of people. The ability to share business logic, utility functions, and even design systems between React app, web apps and React Native mobile apps with a single mono repo became a powerful architectural advantage for large organizations, leading to incredible code reuse and consistency. React Native didn't just compete with other mobile frameworks, it enhanced value proposition of React as a whole. It created a synergistic loop. More web developers learn React because of its mobile potential, and more developers adopted React Native because of the existing web ecosystem. This cross-pollination amplified React presence, contributing significantly to its current market leadership over more siloed solutions. Okay, so now let's look at the continual evolution and architectural considerations. The narrative continues to evolve. While Angular and TypeScript championed the initial shift to robust client-side applications, React's philosophy of learn once, write anywhere, heavily amplified by React Native, has proven exceptionally sticky. Today we see this evolution in full-stack frameworks. Solutions like Next.js for React and the analogous advancements in Angular with features like hydration and server-side render report are blurring the lines between client and server, optimizing initial load time and SEO while maintaining the SPA experience. WebAssembly and beyond. The frontier of front-end development is constantly expanding, with WebAssembly offering new possibilities for high-performance client-side computation independent of JavaScript. Things like Blazor, which Microsoft are offering, are a good example of that. And the developer experience focus. Both ecosystems continue to prioritize developer experience with sophisticated CLI tools, improved debugging, and powerful build systems. For us engineers, the key takeaway is recognizing this architectural journey from server-dominant monolithic applications to client-side SPAs enabled by frameworks like Angular and the power of TypeScript, and finally to the broad spectrum dominance achieved by React, fundamentally propelled by its successful expansion into native mobile space with React Native. It's testament to the power of cohesive programming model extending across diverse platforms. Basically, I think it was a game changer. React Native was a game changer. You want your teams to be able to do the thing. I think that was the thing that basically moved it ahead of Angular in terms of going forward. Okay, so what are your thoughts on this architectural evolution? How has the rise of client-side framework, particularly React and its native sibling, influenced projects in your career? Do you see Angular and TypeScript as the whole unsung heroes of this paradigm shift? Let's discuss the nuances in the comments. Your insights are invaluable. If you found this deeper dive into the history and architectural impact of these technologies insightful, please press the like button, share the video on LinkedIn, or basically just get in touch with me for anything you want to discuss. Thanks for watching this today, and as I always say at the end of all my videos, anyone needs any advice or anything, wants to talk about any of this anything, please just ping me on LinkedIn and I'll be more than happy to talk to anybody. Thank you very much.